I'm Everett Klein, also a member of the Adult School Board, and I have the great good fortune of introducing tonight's talk. As this series, well, maybe I should pause because any of you who go to theater know at this point somebody says, please turn off your cell phones. And then they add, if you have any hard candy and you're going to need it, would you unwrap it now? As this series nears the end of what was a 20-year journey for Marco Polo, we turn to China, a country that is still unknown in many ways, but also a country from which we can learn a lot. We know that much about China. This is especially important as this nation struggles to re-examine and reshape policy regarding energy, land, climate, and certainly the upcoming Copenhagen meeting points out the importance of this topic. Our speaker this evening is James Smith. Professor Smith is a professor in civil and environmental engineering. He teaches and carries out research in hydrology and hydrometeorology. I've never said that word aloud before. He focuses on urban environment. During the summer of 2008, he led an NSF-funded team of researchers carrying out field experiments in the Beijing metropolitan region, examining the impact of urbanization on regional climate and air quality. Appropriately, his talk tonight is titled Water, Air, Land, and Climate, China. Professor Smith.
Thank you. That seems no feedback. Very good. So two things that you probably know about China are that it's experienced dramatic economic growth over the last several decades, and associated with that economic growth have been an associated number of environmental problems, and problems that deal with air, problems that deal with water, problems that deal with land. What I'd like to do this evening is not give you a comprehensive survey of the environmental problems that China faces in the 21st century. That would be a daunting task. But what I'd like to do is point to some of the problems and point to ways in which problems associated with water, air, land, and the coupled resources are linked together. One of the other things that I'd like to do is put the problems that China faces in the context of the United States. And in many settings, it's a context in which China has emulated policies that we've developed in the United States. And in some cases, it's going to be the United States looking to China for examples in the future. The image that you see here, you may recognize one of the new icons of China. It's the Three Gorges Dam on the Yangtze River. And that's going to be the focus for much of what that I'm going to present today. So I'll be looking in the Yangtze River. I'll be looking at Three Gorges dams and the couple problems of water, air, and land resource management in China. So the Yangtze River is one of the central cultural resources of China. From the perspective of economic development, we have some of the largest cities. Shanghai on the coast, Chongqing in the western portion of the intensely developed central portion of the Yangtze. Wuhan and Nanjing also very large, important economic centers. China is certainly a very diverse country in terms of topography, in terms of physical features. We have mountains and deserts. We have lush environmental settings in the central portion of the basin. And the Three Gorges Dam is located right in the middle in a mountainous region of central China. And the Three Gorges Dam is used in China as one of the central development tools moving forward during this period of rapid economic growth. Now, last week in the Wall Street Journal, there was a wonderful little story that dealt with Three Gorges Dam. The title of the story, "Drought Poses Obstacle for Giant Chinese Dam." And it really encompassed the range of problems that China is facing and wrestling with now, problems that deal with its economic development, problems that deal with its ability to feed its population, problems that deal with economic, with environmental degradation. Now, the central issue that arose last week is the Chinese government decided not to complete the filling of the reservoir behind the Three Gorges Dam. Now, that's important. Three Gorges Dam is a hydropower project, and to reach full hydropower production, you've got to get the dam up to the top of its pool level. And so the decision was made not to do that. And there are a variety of reasons that are speculated on, none of which were articulated by the Chinese government. The principal reason is a drought that has been experienced in the area of the Yangtze River Basin upstream of Three Gorges Dam, so severe drought. Now, the problems that the Wall Street Journal article points to that are related to the drought are ones in which agricultural production is down, and they have concerns about the water availability for agricultural production. There are environmental problems downstream of the dam, and how can they effectively manage those? There are also problems that have been pointed to in terms of the adverse effects of the dam and raising the pool level on the surrounding environment. There have been a series of massive landslides as the water moves up through the gorges and increases the water in the adjacent soils. So that's been a concern. Another concern has been, there are little cracks. All dams develop cracks, but it's kind of a scary thing in the Three Gorges Dam. There's a lingering concern there. And one of the things that we'll see is there's actually a good reason in China to have that concern. So the concern is that if you fill it, structurally the dam will not be able to withstand the forces that it's subjected to. So all of these come into play in this marvelous little article. A backstory to it is that is this the new reality that the Yangtze River faces? Are we seeing a changing climate that's going to alter the water availability, and what is that related to? So all of these questions are ones that are speculated on in the story, and there's certainly issues that scientists and engineers speculate on in connection with resource management in China. And I'm certain that there are issues that the Chinese government officials are wrestling with. And at some level, they simply don't know what to do in the face of a broad array of problems. And so that's one of the things that I want to describe to you, or what are the range of problems that China faces associated with this rapid economic development and its impacts on water, air, climate, and land, and the integrated nature of all those features. Now, air quality is certainly one of the elements that's received tremendous attention in China. The 2008 Beijing Olympics brought renewed attention to problems of air quality. I'll tell you, I was in China immediately but prior to the Olympics and had a team there all summer. I was just stunned that everything went just fine. When I got on the plane before the Olympics, I couldn't see 100 meters in front of me. So I was just amazed. Now, Beijing really doesn't compare with Linfan, which holds the distinction of being the world's most polluted city. Now, it's not a unique distinction in China. Of the World Bank's list of the 20 most polluted cities in the world, 16 are in China. And they're concentrated in the area around Linfan. And there's no mystery to this. This is the coal production area, and it's also the area in which there's been tremendous development of coal-fired power plants and the industries associated with that. So this is the industrial heartland of China, and it is the most polluted location on Earth at this point. So the air quality is terrible in this region of East Central China. There are certainly major public health consequences, impossible to know with tremendous amount of accuracy what the consequences are. The World Bank estimates that there are about 600,000 excess deaths per year associated with air and water pollution, and the bulk of those are from air pollution. Now, one question might be, is this related to Three Gorges Dam and the water story? It is. It's related in two very important ways. So one side of the story in China is that we have these coal-fired power plants that are producing a tremendous amount of pollution, and one of the ways that we can deal with that is this shift to hydro. And so Three Gorges Dam fits into that part of the story. The improved air quality, the contributions to reductions in greenhouse gas emissions, Three Gorges Dam plays into that part of the story. So they're linked in that way. But they're also linked in this drought story, potentially. And the drought story is one in which the emissions from power plants, industrial facilities, and cars are having a pronounced impact on regional climate. And so this other side of it is the drought that we're seeing in the Yangtze. How is that related to this air quality story? So that's one that we're going to have to wrestle with. And more broadly, the issues of climate impacts on air quality. So I just want to give you that notion now that the story in Linfan is related to the Three Gorges story. And I'd just like to plant one other notion in your mind, and that is the notion that the air quality problem is linked to another really big problem in China, and that's agricultural production. And what I'm showing here are just some analyses of the effects of air quality on agricultural production. This is principally in the Yangtze River Basin in the heartland of agricultural production. It's one study showing 1990 and then projected 2020 impacts simply of ozone. So ozone is going to increase in concentration associated with emissions from power plants and from automobiles. So elevated ozone levels are certainly viewed as one of the major air quality problems in China. It turns out there are also potentially major problems associated with agriculture. There have been other studies looking at air quality in agriculture. Simply, you look at these cities in which the entire atmosphere is shrouded, and one of the principal things that happens in those settings is that you reduce the light that reaches the surface. And so simply having these elevated aerosol levels reduces the incident solar radiation, and that has a big impact on agriculture. Denise Mazeral in the Woodrow Wilson School here has been doing some really interesting work on this problem, and Denise thinks that the big story may be air quality in agriculture. But for now, it's just going to be a side story, and I want you to keep it in the back of your mind that when we think of air, water, land, and land resources, that they may be linked in this way as well. Now, if we look at the energy side, there's some simple ways of saying, well, yes, Three Gorges can help. So the blue line here would represent the contribution to the total electricity production in China from hydro, and it's going to increase more. But what you're seeing in the red line is essentially the dramatic growth in coal-fired power plants in China. That's what's fueling the economic growth. The hydro is going to help. You know, that coal-fired contribution would be worse without Three Gorges. But the fact of the matter is that it's not going to be a solution to the problem. It's going to contribute. Renewables, wind and solar, maybe down the road they'll help more than they currently do. Nuclear may come into the picture in a bigger way for China as well. But the story is going to be one in which coal-fired power plants play a big role. It's not entirely a bad news story, because one of the things that's happening is that the really inefficient power plants that dot places like Linfan are being replaced by higher efficiency coal-fired power plants, and power plants that are increasingly adopting U.S. technology for removing sulfur dioxide and other pollutants. So the story is not entirely bad, but you have to keep that picture that coal is going to be a part of the story in China, and hydro is going to mix into the story. Now, what was Three Gorges designed to do? So there's a long document that was developed in the 1950s after the communists took power in China. It turns out Chiang Kai-shek had developed many of the ideas in the 1930s and the 1940s, or had developed the documents, and the communists retained them. Now, they list 5 principal objectives. They begin with navigation, and navigation is certainly important on the Yangtze. A lot of the commerce from Shanghai to Chongqing is transported inexpensively on the Yangtze River. So that's important. It's kind of a little quirky being up there, number 1. Flood control, as we'll see, is a really big deal, and we'll just see how big it is in the 20th century. So that's a big deal. They point to conservation, and conservation is both soil and forest conservation. And then comes hydropower. You know, so hydropower is really the deal when you get down to it. But it's 4th on the list here. And then finally, they have this notion of really what we're looking at is economic development. And they point to rural electrification. It's a poor area by and large, and so we're going to raise the level of this up. Now, does it look familiar at all to you? And it is familiar because they've just taken it directly from the Tennessee Valley Authority. So the Tennessee Valley Authority is the model. And if you look at the design objectives of the Tennessee Valley Authority, this list is taken directly. And in fact, Three Gorges, the ideas behind what Three Gorges would do are really driven by the TVA model. Now, the quirky side, there are a few elements of that. Navigation is first in the TVA because it has to be first. It has to be first because the Tennessee Valley Authority, it's not in Tennessee, it's not in Georgia, it's not in North Carolina, Virginia, or Alabama. It's in all of those states. And Franklin Roosevelt is spending tremendous amounts of money. First thing he signs after he takes office is the enabling legislation for the TVA dams start work. The federal government plays a big role. And the federal government can play a big role because it's a navigable river. And that goes back to the Supreme Court decision in the John Marshall Court in 1824 that dealt with steamboat commerce on the Hudson River. And so in the United States, the legal framework is such that navigable rivers give the federal government the authority to manage the resources associated with that. And it's a cornerstone of our environmental legislation, from the program of flood control and resource management that the Corps of Engineers and the Bureau of Reclamation developed to more recently the Clean Water Act. So China's a different story, and China's a very different story. the Chinese government, as you well know, has the authority. They don't need the Supreme Court decision. They have the authority to do things that are more difficult in the United States. But that's why navigation appears first here. And then the others are important. This notion of rural electrification and economic development, it was central. And it was an important idea that's been adopted around the world. Itaipu Dam in South America is the second largest hydropower facility now behind Three Gorges. And the idea is that Itaipu would provide for economic development now for countries, principally Argentina and Paraguay, in the TVA model. So the TVA model has been broadly exported for development, but now the world doesn't really see it as the TVA model, and it's really going to be the China model that comes into play. And so the China model is going to be massive construction projects for economic development, and Three Gorges embodies those. So that's looking forward the way the story will play out. Floods are a big deal. And floods probably would, in a realistic ranking, would be right up with hydropower production. China has had the worst floods in the world in the 20th century. The worst was the 1931 flood, and this is the National Oceanic and Atmospheric Administration of the United States did a survey of the worst flood disasters. The 1931 is the worst. Now, 145,000 fatalities. 145,000 fatalities. As recently as 1998, 4,100 fatalities from flooding. 140,000 in 1935, 30,000 in 1954. Now, the quote from Mao is in 1955, not surprisingly at all. So Mao's quote reflects two realities of the development of Three Gorges in China. One is a reality that's reflected in this idealized artist's rendition of what Three Gorges is. It's a monument. It's a monument to the greatness of China, in the same way that Hoover Dam served that role in the United States in the 1930s and beyond. So there's that element to it. The other element is it's 1955, and there have been tens of thousands of fatalities, direct fatalities, larger number of deaths associated with famine and disease, and it's a big problem. And it's a problem that has to be responded to. So these elements come into play. China has, and the Yangtze has, a flood problem that is hard for us to conceive of in the United States. Now, a different view in the United States, some common elements and some very different elements. So we've had big floods, the 1927 flood in the Mississippi River, the 1936 flood, most severe in Pittsburgh, the 93 flood, the Great Flood of the Mississippi of 1993. If you look at the number of fatalities, we can stretch into the hundreds in 1927, but we have a totally different perspective on what this hazard means in the United States. So that's one side of it. The other side of it is just like Mao became proactive in 1955. What happens after the major floods in the United States is political action. The Flood Control Acts of 1927 and 1936 are the principal elements of federal legislation that dramatically changed flood protection in the United States. So a dramatic change, putting the Corps of Engineers in the business of protecting the public against flooding. Now, there are different perspectives on flooding. Mark Twain has a slightly different perspective than Mao. The sort of iconic side of engineering is not as strong with Mark Twain as it is with Mao. Now, but to be fair, it's not as strong with Mark Twain as it is with the Corps of Engineers or with the Bureau of Reclamation. We have the same mindset that developed over the 20th century in development of flood protection for the United States. So the central element here is that catastrophes are going to lead to stimulus of the political process. And so in '55, that's when Mao becomes convinced. He puts Zhou Enlai in charge of Three Gorges. He can't get the Soviets to spring for the money because they're having problems. So it'll be the 1980s before Three Gorges ultimately gets back on the right track. Now, in the Wall Street Journal article, they point to a concern about dam failure, and there's a good reason. China has by far the largest rate of dam failures in the world. It has the worst dam failure in the world. The 1975 failure of dams on the Wu River, which is in the mountains just north of Three Gorges, in fact. 62 dams failed. Now, it's principally two major dams, Bangkao and Shimantan, failed, and then a cascading sequence of failures. 26,000 direct flood fatalities is a very, very low figure for the total deaths. The official government figure of 145,000 is probably much lower than the actual number of deaths. It was a bad storm, more than 40 inches of rain in 24 hours, but it was also bad design of the dam and the system of dams. China they've had more dams fail than the rest of the world combined. They built dams principally in the 1940s and the 1950s, and they fall down. And lots of people die when they fall down. So when the Chinese worry about Three Gorges Dam failing, there's good reason for worrying about it, because they just don't have the track record now to show that they can do this effectively. My sense is that Three Gorges is well designed, well constructed, and it's not a part of this same design process. But reality and perceptions can be two very different things, and perceptions are really only going to change slowly. In the United States, perceptions were set on June 1st, 1889, when more than 3,000 people, it doesn't sound large compared to what China sees, but more than 3,000 people die in Johnstown, Pennsylvania from the failure of the South Fork Dam. And that colors the way dams were viewed throughout the 20th century during the period of massive dam building in the United States. So different histories. Federal dams in the United States don't fail. They're over-designed. They're conservatively designed. And in part, that ties back to perceptions. And perceptions are that dams are dangerous things, and that perception was set in 1889, and it carried through much of the 20th century. So dams have that story there. Three Gorges Dam have this wide array of human element dimensions to it. 1.2 million people being relocated. Dams in the Missouri River led to hundreds of people being relocated, and it was a massive political issue. Now, it was a big political issue and an important set of issues because there's Native Americans being displaced from their lands. There's that sort of thing going on. But in China, completely different. 1.2 million people being relocated. Social engineering, so not just the idea of relocating these people, but reorienting the industry, moving them to different places to do different things, as an idea that evolved from an association with Three Gorges. Now, a variety of looks at land use in China. Much of the forest cover is in the southern portion of China and the Yangtze River Basin. Now, the figure on the upper left is for the period prior to 1993. Then 1993 to 1998 on the lower left. The thing that's important about these these representations of land use is that as we begin this dramatic economic growth, there is a dramatic transformation of land use. Forest cover is diminishing rapidly, more rapidly than any place else on Earth, and principally in the Yangtze River Basin. So a dramatic transformation of land use, and it's a bunch of things. A lot of it was actually going into agriculture. And so with this transformation, there are a number of issues that arise. And one is that we need to either conserve the existing forest or we need to reestablish forests in places where it's been left. There's the growth of deserts is a real concern. There's the climate change side of the story in which you get points for having forest cover because it'll sequester the CO2. And so that's a good thing. You want to keep the forests for climate applications. In fact, part of the IPCC process has pointed to enhancing and retaining forests as one of the important elements of managing CO2. Now, the forest conservation, the ideas were that, all right, so we need to be good citizens and provide this forest cover for CO2. It's an important aspect of the environment. None of that really played a major role in the policy decisions that were made right after 1998. And the idea that really took hold is that what we've done is we've created this tremendous flood hazard by transforming land use from forests to agriculture and urban. And the notion that underlies that is that forests prevent floods, and it's a very, very old idea. And so the program to reforest, to preserve forests, was really driven by this 1998 flood. It got a lot of money. You may have read about the November 2008 stimulus package, larger than in the United States, and a big part of it was for environmental protection, and there was a large program associated with preserving forests and regrowth of forests. Now that all ended this year. It ended this year because of tremendous agricultural shortages, and so we can't transform agricultural land to forest. And so this is the range of problems that the Chinese government is wrestling with. So forests are important because they prevent floods. But oh my gosh, now we're losing. We've got a drought that's leading to shortages of agricultural production. That won't work, all right. And so what we're seeing is this rapid cycling from problem to problem in China associated with these issues. So the land use side of the story is an important one. It's an old one in the United States. The conservation movement dates back to the 19th century. John Wesley Powell, who traveled down the Colorado River, is one of the principal architects of the conservation movement in the United States. It's important to distinguish two very, very different flavors of the conservation movement. There's a preservationist movement, now it may go under the rubric of an environmental movement that is to preserve pristine environments. And then there's the streak that John Wesley Powell and Gifford Pinchot and others promoted, which was for efficient management of resources. Now it would go under the heading of sustainable development. And so that's what Powell was promoting. And much of what Powell promoted really was driven by ideas of water scarcity, principally in the western United States, and the idea that all of these resources are linked, like the Chinese are viewing them now. Forest resources are linked to our water resources, and the reason that we manage our forests is to protect our water resource. And that was an idea that Powell promoted in the 19th century, and it became a central element of this efficient management stream of the conservation movement in the United States. Also, this notion of water being the central resource and looking at management of all of the others. your agricultural program, your forestry program, your urban development program, tying back in to the ability to provide a sustainable, secure, and safe water resource. Ideas of John Wesley Powell's. Now, Powell, of course, is most closely associated with the Colorado River and Colorado River Basin. And now it is our principal water resource and power production for the southwestern United States, Southern California, Arizona. It's tremendously important, and it's a scary story in the United States. The same way drought in the Yangtze is a scary story in China. The question is whether the drought of the 21st century in the Colorado River Basin and the extraordinarily low lake levels for Lake Powell behind the Glen Canyon Dam and Lake Mead behind Hoover Dam reflect the new norm in climate, or whether they simply reflect climate fluctuations. And there are reasons to think that in this particular setting that we could be seeing regional climate fluctuations. And those are the kinds of issues that will be very important in the United States, and they're very, very important in China. And that's the drought story in China. The drought story has received a lot of attention. Now, the busy figure on the upper right just shows China, and it shows black triangles and red triangles. And black triangles are essentially locations in which precipitation has been decreasing over the last 3 decades, and the red triangles are areas when it's been increasing. And so there's a consensus now that there's a pronounced decrease in precipitation in East China, centered on the Beijing area, and just to the east of this Linfan coal production area. There's an increase in the lower portion of the Yangtze River Basin. That's some of these red triangles that show up. There's also a consensus that it's the aerosols. And so that's that haze that you see in the pictures. It is the aerosols that are responsible for it. Now, there's not a consensus why, and there are a variety of hypotheses that are floating around, and it's important to sort out which of those hypotheses are right, because they actually have very different policy implications associated with one. So getting out, so microphysical, what is that? Well, so aerosol particles, you can think of little pieces of dust, and some of those can serve as locations on which water goes from vapor to liquid, and you get cloud droplets. Now, it seems, and they're called cloud condensation nuclei, and it sounds like it would be a good idea for more rain to have more of them. Okay, good idea. If you take more water from the gaseous vapor phase and put it in the liquid, that should help with rain. But it turns out that exactly the opposite holds. That what you get when you have lots of these little particles on which water vapor can condense is you get lots of cloud. You take your water vapor and you waste it. You don't build rain, you build cloud. And so you get this haze that we see throughout the coal production areas of China. So the coal is a bad thing. It's a bad thing because it's going to use up your water. Now, there are other ideas that are more complicated, and they revolve around the fact that this haze is really affecting the amount of radiation that reaches the surface. And it's changing the way the atmosphere is heating. Thunderstorms really depend on the way the surface and the atmosphere heats up. And so what you're doing is you're really just changing that side of the atmosphere. And so there are two very different ideas about what's going on in precipitation, and which is right and which is wrong have big implications for how you would go about trying to change it. So those are issues that deal with regional climate. They're very important. The upper left image is just the Beijing metropolitan area, and so the water supply dams for Beijing are overstressed. Beijing has chronic water shortages, that if this continues, this decrease, the chronic water shortages are going to be a tremendous problem for the Chinese government to deal with. But this is a regional story. Now, looking at global climate for a second and talking about Copenhagen, the Intergovernmental Panel on Climate Change, they assess what we know about climate change. And the important thing here is actually the bottom line, the scientific knowledge. And so the scientific knowledge side of things says that if you tell me how much CO2 you're putting into the atmosphere, you tell me how much methane, how much nitrous oxide, I know what the radiative impact is. There's not uncertainty in the science there. You tell me the CO2, fine. I know what's going to happen. Now, there are issues about, sequestering it and vegetation and things like that, but you tell me how much CO2 is going to the atmosphere, and I know what it's going to do. And that's the assessment there. Now, the one that is bad is this aerosol indirect effect. It's a tremendous cooling effect, but we just don't know how big, how important, how pervasive it is. And that's the business about building clouds and not building rain. So you take your water and you turn it into clouds that have tremendous impacts on the radiative forcing. And so it's a big cooling contribution. It's very regional in nature, where you have the large aerosol loadings. Where we have large aerosol loadings, this is a satellite analysis of aerosols from a global perspective. The gray areas are just deserts and ice where the satellite doesn't work. The darker areas are where we have high aerosol loadings. And I'll just point out a couple of things. The deserts of the world and the Sahara and the Gobi and up around the Himalayas are areas where we have tremendous amounts of aerosols that are produced. The other areas where we have tremendous amounts of aerosols are where we have biomass burning. And so looking into the central portion of Africa, looking around the Pacific Rim of Asia, those elevated aerosol loadings are principally from biomass burning. But then the big one, the hot spot, is Linfan and this coal production area of China. So it's the highest aerosol loading in the world, and it's a pervasive loading that sort of day in, day out, we're going to have these high aerosol loadings. So when we think about the global perspective, this is kind of the story. It's really China, places in Africa, and areas in the Pacific Rim that are really going to have big regional effects, and those big regional effects are going to translate into smaller global impacts. Now this is just to give you the picture. The top one in Beijing on October 21st shows just a typical day. 2 days later we have an atypical day, a blue sky day in Beijing. And then the bottom image just shows this haze of aerosol covering East China on a typical day. So this is the setting in which China has to alter the way it manages its energy production. Now, as you heard earlier, in 2008, the Beijing Olympic Games, like most of the Olympic Games, turn into a huge field experiment. And so all of the Olympic Games, going back to the Atlanta Games in 1996, have had big components associated with how the atmosphere works. Now, it's driven in Atlanta, it was, we're going to have thunderstorms, and it was improving prediction. It was driven by the fact that the urban environment heats the surroundings, and how is that affecting the climate. Those were things that were looked at. In Beijing, it was simple. It was this wild experiment that the Chinese government carried out. And the experiment was to dramatically reduce emissions. Emissions from power plants, emissions from construction activities, and emissions from automobiles, the odd even driving days, all of the diesel taken off from a certain period. The taxis, the ubiquitous taxis, dramatically reduced in number. So this bizarre experiment was carried out in which we have these tremendous emissions and they're reduced dramatically. Now, PM10 stands for particulate matter finer than 10 microns. It's the standard measure that the Environmental Protection Agency uses for characterizing the amount of aerosol in the atmosphere. And so what we see is that we have dramatic reductions that take place associated with the transportation corridor, and then these little points that are actually associated with either power plants or industrial facilities that are shut off. And so the question that was being examined by our group from Princeton, colleagues from other universities, and a number of other groups, is what is the impact of this dramatic reduction of emissions on regional climate? And so we had a variety of modeling and monitoring efforts that we carried out along with colleagues in China from the Institute of Atmospheric Physics. Principally driven by these questions of, what is it about the aerosols that are leading to changes in regional climate, especially as it relates to precipitation. So those were the stories that we were looking at. Now, you're not going to like this, and you're going to say this is so typical. But it's the answer. It's complicated. It's complicated. So in looking at aerosol and intense rainfall, which is one of the things that we focused on, and so the figures in the bottom just show analyses looking over the entire Olympic period, one that reflects the reduced emissions, BAU stands for business as usual, and it's looking at rainfall over the entire Olympic period. And you can stare at it. There are certainly changes that take place. And you can stare at it from day to day, and there are differences from day to day. But a big conclusion here, as well as in other settings, is that, you can either, in a particular setting, you can either get more rain or you can get less rain, or you can just move the rain around to different places. Okay. And so that's part of the, it's complicated story. Now, it gets a little better. It's complicated, but we're beginning to understand, what leads to more rain, what leads to less rain. Now, so it's not just, you reduce by 10% the aerosols and you get an X% increase in precipitation. That would be simple. The complicated side of it is, you reduce the aerosol loadings, and in a particular environment where you have a certain amount of water vapor in the air, that's going to give you more rain. With lower water vapor, you may get less rain. With a more unstable environment, you get more rain. With a less unstable environment, less rain. So we're learning those stories. And those stories ultimately translate into looking at what is responsible for these dramatic changes in precipitation. But the complicated bit is that you can't tell a policymaker, cut emissions by X%, and you're going to see a Y% increase in rain. That's simply not going to happen. And so that's the piece that in looking at reducing emissions, it's going to be very difficult to say, this is what you're going to get from it in terms of changing the regional climate. It's a good thing, you reduce the SO2 emissions, and the 600,000 excess deaths is really going to go down. That's a good thing. So it's a good thing. But you also have these problems that are tied into, Beijing doesn't have enough water, we get drought and flood in the Yangtze, and we think it's tied to the way we manage our emissions and the way that's going to play out. So these are the problems that the Chinese government faces when they look at the decision of, do we go ahead and raise the Yangtze to full pool? They're dealing with just an enormous array of problems that deal with the way water systems, land systems, and climate interact. They're dealing with systems in which it may have profound impacts on agriculture, and it may have profound impacts on the capability to sustain the economic development. So it is going to be complex. The Chinese government has tremendous challenges. We certainly hope that they're able to navigate those and show much of the rest of the world how we can, in fact, move toward sustainable economic development in ways that allow us to manage within the existing resources. So the Wall Street Journal article stands, and the basic story that I can tell you is just stay tuned. Thanks. Questions? Yes?
How much do earthquakes and earthquake zones play in the failure of the dams in China versus those in the U.S.?
So there are concerns in several areas in the U.S. New Madrid zone is one. There is a fault zone that is fairly close to the Three Gorges Dam, and that is a concern. There have been failures of dams associated with those sort of structural features. Mulholland's Dam in California is the most famous in the United States. But in China, most of the dams that have failed have been just simply from overtopping. The seismic side comes into play, and there have been dam failures associated with seismic. But unlike in the U.S., their dams overtop and fail. Yes?
Why is there not more nuclear done?
I don't know. The simple answer is that it's expensive. So you look at the TVA example. The Tennessee Valley Authority, while it had all of these elements of development associated with it, rural electrification, flood control, ultimately what it became was a power company. It's essentially a wholly owned subsidiary of Duke Power now. And it's not one that's making money because it invested in nuclear in a big way. And that mindset holds back nuclear, that it's simply too expensive to add to the mix. I don't know what the thinking would be in China on how they would phase nuclear in. Yes?
You talked about the effect of drought on reducing hydroelectric generation in China. In this country, I guess there have been incidents where there's been a need to cut back on fossil generation because you haven't had enough cooling water available. Does that happen in China as well?
I don't know. So the nuclear power plants haven't been a big part of the mix, and the nuclear power plants are principally sited on the large rivers, and so they have adequate water for the ones that I'm familiar with. So I don't know how that story plays out. Yes?
The question, the design level for the dam, the water behind it, was that at one time about 185 meters?
For the Three Gorges?
Right. Or where is it? It stopped somewhere now, at some level?
Yeah, so they've stopped at some level below maximum pool, and I don't know what the precise maximum pool level is. They've stopped. So they are releasing water that they could be storing. They're releasing water in excess of what they absolutely have to release for downstream uses. So they've made a conscious decision not to expand the pool.
And how is that affecting the power generators that are supposedly in the dam?
Well, so the power generators were completed in October of 2008. That was sort of the last round of generators that were installed. All of the generators are in operation now. They're just not at peak capacity. So peak capacity would be with the largest elevation in the pool, and that's what they've not been willing to move up to. Yes.
In your opinion, are we having a global warming or a global cooling?
Global warming or global cooling. The consensus is that global warming is locked in. So that's certainly something that I think is not only the scientific consensus, but it's absent just dramatic effects associated with this aerosol impact. Then the warming is going to be easy to quantify from a global perspective. The thing to point out about the aerosol side that is very different from the CO2 is that we could shut off coal-fired power plants and reduce the aerosol load dramatically in a matter of years. And so that's actually manageable. The CO2 problem is locked in. And so that's, over the long term, really going to be the concern. Perversely, if China really gets serious about SO2 reductions in its power plants, that's going to reduce the main source of cooling. And we would expect to see the warming increase more rapidly. Yes?
There was a talk yesterday that addressed the issue of global warming and the melting of the Tibetan glaciers. Are the Chinese starting to address that issue, do you think?
The Chinese have this in the mix. And so you've seen the recent news articles that the Obama administration and the Chinese have committed to emissions reductions. So they're moving forward on problems like the forest and CO2 sequestration. That was identified in the last IPCC report as one of the simple ways of enhancing and slowing the rate of CO2 growth. And the Chinese bought into that. Now, they bought into it, but then when it looked like it was going to conflict with agricultural production, you can't have the population without food. And so the forestry program went by the side of the road. And I think that's one of the principal problems that the Chinese face is they can't just look at climate change, or they can't look at hydropower production to reduce the reliance on coal-fired power plants. They have to deal with this broader range of problems that are interrelated, and that's what is the biggest struggle.
When the dam was first being designed, there was an estimation that it would not contain nearly as much water because it's such a very silty river that it will silt up very quickly. Is that happening?
I don't know. So the novel aspect of the design is that unlike most dams, which are purely sediment traps, Three Gorges was designed to actually transport a fair amount of the sediment through the dam and sluice gates. I haven't seen data on how effective that's been. The Chinese claim that it's been effective. It turns out to be extremely difficult to measure sedimentation rates in dams. It's even been difficult to figure out how rapidly Lake Mead and Lake Powell are filling with sediment. So I think it's going to be a while before we have a clear picture on what's happening with sediment. But it is the other reason that the Chinese have been so concerned about restoring forest cover, because it's the erosive side of agricultural production and the increased sediment loads that they worry about.
What regional countries outside of China are being affected by what's going on in China, and aren't they
very unhappy with any negative effects?
Yes. Number one is certainly Japan. So they have elevated ozone concentrations that are clearly linked directly to China, and that's aerosol. Of course, they have elevated aerosol loadings from China. A bunch of other trace gases. So Japan is certainly number one, and what I would expect is increasingly Japan and China negotiating over environmental cleanups. That's where a lot of the climate change picture is going to develop from an international perspective, is those regional agreements that have to be struck to bind governments to action. Yes?
I've read about methane gas and its contribution
Yeah.
to global warming, and particularly coming out of India. Do you have any comment about that?
So methane, one of the agricultural areas are certainly major sources for methane, and the way agriculture is carried out is a big part of the methane story. It's a very, very potent greenhouse gas, and so the bang for the per molecule of methane is much larger than CO2, and a lot of attention now is being placed on controlling methane as a way of getting more for your money in terms of eliminating trace gases from the atmosphere.
What's the main source of that?
Agricultural production is yes, yeah. Yes.
Are there other dam projects, either new construction or planning stage in China that
it's not a dam project per se, or I guess you could view it as a massive dam canal project. I didn't even talk about the Yellow River. The Yellow River is certainly in much worse shape than the Yangtze. One of the statistics that I recently saw about the Yellow River is the lower portion of the Yellow River was dry for more than 280 days last year. And it's a big problem in terms of the water resource. It also has these climate dimensions associated with it, particularly with this growth of the desert region. So why not take water from the Yangtze and just send it over all those mountains all the way up to the Yellow River? And so that's a project that dwarfs Three Gorges. It's one that at the same time they shelved the filling of the pool in Three Gorges. There was an announcement that they suspended development on the Yangtze Yellow River diversion project. So that's a massive one. There are a number of large dams that will be built and that are being designed in the Yangtze River Basin. So these dams that failed in the Ru River and led to these catastrophic loss of life, all of them have been rebuilt. Now they've been rebuilt better. That's the good news. But China is committed to these massive structures as an important part of the way they're going to manage their resources.
Given the history that they've had, they got now the engineering management skills, abilities to do these things, what we would call better, well enough to be relatively safe.
That's an interesting question. I remember I was a graduate student in the late 1970s and at Johns Hopkins. And one of the first delegations of Chinese scientists to visit the United States came, and precisely what they wanted to talk about were dams. And the thing that was striking about it was that you would ask them a question. And so the question could be as simple as, now that you've resumed publishing scientific and engineering articles, how do you plan to do X, Y, and Z? The answer was always, since the Gang of Four were deposed, and then the answer. But it was, the message is that there is this missing generation of scientists and engineers. And so in that group, there were 20-year-olds and 70-year-olds. So now those 20-year-olds are approaching 50. China has a good and improving education system, and they have a huge cadre of very, very well-trained scientists and engineers. Some locally. The other big development is that now all of our Chinese graduate students from Princeton are finding more opportunities in China than in the United States and Europe. And so what we're seeing is this rapid relocation of capital, of intellectual capital back to China. So I think like the economic development, their intellectual development is growing by leaps and bounds. Yes?
You showed a chart depicting contribution of coal, nuclear power to energy production. And you had a line there for renewable energy sources, which was
0.
So China's announced that they're going to invest about $500 billion in renewable energy sources over the next 5 years. Is that going to have any impact on that line?
If they're investing if they're really investing $500 billion, it better have an impact. Three Gorges, to give you a frame of reference, is $25 to $50 billion of the total cost associated with Three Gorges Dam. And so they have to be thinking that in the long term they're getting from that investment something like 20 times a Three Gorges bang for their buck. I have no idea how they're planning to do it. They could, solar and wind are all plausible, but they require that kind of investment to scale them up to satisfy the demands that have been generated. Let's see. I think that yes.
Was that Three Gorges decision not fulfilled? Is that a permanent decision, or are they still looking for ways to fix the problem?
So the official plan has always been that it would fill by 2012, and so they're well within the official plan, and so it's still 2012 is now the plan. They had been filling more rapidly, and so this is really a departure from what they had said as a revised plan. They had announced that by December of 2001 they would reach full pool level, and they have decided not to do that. I am sure that by 2012 either serious problems are both unearthed and become public, or they will be at full pool level. You produce a lot more power, when you have it up 10 meters. Yes.
On the chart, you showed the relationship with different areas between thermal and hydroelectric.
Yeah.
It really only went to 2005.
Yeah.
And so Three Gorges didn't come on stream until 2008.
Yeah.
So doesn't that do sort of understate hydroelectric in China? My understanding is that Three Gorges would produce something like almost 20% of the necessary power.
Yeah, so the 2005 does include the initial power production from Three Gorges, but that will increase. That increases linearly over time. It doesn't increase more rapidly than that, which is what the coal-fired power plant production has done. So unless they are able to scale back the demand, then the percentage that hydro provides is still not going to keep up with the coal-fired demand. Yes.
In addition to power, what is the impact of automobile use and quality expected? What is the growth there?
The growth has just been stunning in automobile production. And there, the big problem that emerges is the ozone, the elevated ozone levels, and the volatile organic compounds and the NOx that are produced by combustion engines are really the ozone precursors that have led to dramatic growth in ozone. So that would be the big problem, and so it's that's the principal public health concern. Again, Japan is very concerned about elevated ozone levels associated with principally automobiles in China. And then this story of reduced agricultural production is one that's getting increased traction as well.
Thank you. Thank you. That was great. Very, very informative.
Great. Thank you.